Hey, what's up, guys? This is Sheng here. So let's talk about this week's weekly contest problem, number 1625. A lexicographically smallest string after applying operations. I hate this problem, because it's wastes me a lot of time on it. Okay, sorry, I'm a little bit running my nose, so okay, so bear with my voice here, guys. Okay, so you're given like a string of even length consisting of digits from 0 to 9, okay, and two integers a and b. Okay, so you can apply either of the following two options any number of times in any order on S. Okay, so basically, add a to all the indices of S. Okay, and after adding that, so you need to do a modular by 10, right? Basically, it has to be in the between 0 and 9. So that's the first options you can do. The second one is you can rotate the string by B. Okay, so this is pretty easy to understand, right? So you rotate by 1, and then the 3, 4, 5, 6 becomes 6, 3, 4, 5. And they ask you to return the lexical, basically the smallest string you can get. Okay, and then it gives you a few examples here, like you can either do that and do this, and then you just get the smallest one. I spent a lot of time, trying to find a pattern. Basically, I wasn't thinking about the brute force way. I was thinking about, hmm, there should be a pattern, right? Something like this. I mean, uh, let's say if we have a 5 here, right? Seems like we can like rotate by rotating the 5 by 9, we can make this 5 becomes 0. Okay, and then after that, maybe we can do some rotate. Because I was in that path, and I was trying to figure out a pattern, something like this. And then maybe I can rotate this number until it's become to 0, and then I do a ro and I do a shift. I was thinking about more like a greedy approach. But you know what? I waste a lot of time on it. But it turns out this problem is nothing more than a brute force, a DFS. Basically, at each of the state, you either do a A operation or B operation. Okay, and then when's the endpoint? Basically, we just record all the different ads we have seen so far, right? I mean, until we have seen everything, and then that's when we stop, right? We just brute force all the possible ads at one state. We can do two things. We either add A to all the positions, or we do a rotate by B. Yeah, so that's that. I don't know. I don't know why I stuck with that greedy approach or trying to find a pattern for such a long time. Anyway, so that's a different story. So to do that, we can either do a DFS or we can do a stack. So for this one, I choose to use a stack, right? Because it's easier and it's faster, right? So of course we need to have a set scene, right? So that will help us to record all the possible as we have seen so far, right? And then we have a stack. So at the beginning we have S, right? That's a starting point. And then I define like an S here, right? So because we have answer here, because we're looking for the smallest, the lexicographically smallest in the string here, right? So I mean, how to compare a string here? Okay, since it's only the numbers there from 0 to 9, so I just use this. I just use 9 times n. Basically, I just initiate the answer, right? The answer with the maximum possible numbers, right? Strings. In our case, which is the only consists of 0 to 9. So now we have this, and then we can simply do start our DFS search. And in the end, we simply return the answer, right? So so we have a current s, right? So we do a stack dot pop, right? And then here we can simply do every time we have we have a s here, we just update, right? We update this as we update the answer with the current s, right? So that's that. And then let's do our two options, option one, option A, right? And then option B. And option B here. So for option A here, right? So it's nothing more uh, than the just update, right? So we just do a for I in range of the uh, 1 to 1 to n, and the step is 2, right? So for each of that we have a so the new C is what? So we have a so the number is the current string is current s, right? Of the I, that's the current one. Basically, we need to add these things. So we have a C, right, equals to the current s I, right? And then we just need to add it, increase it by a, and then we convert it back, right? And then we do a mod. So to do that, I just need to do this, right? Basically, we just need to convert it into an integer. It plots, we increase it by a, right? Since a is also a string, we also convert it to integer, and then we do a modular, right, by 10 to get the new value, okay? And then we also need to convert it back, right? So new C equals to this, right? So we have to convert it back to string, right? So I know it's a little bit trivial, but annoying, but that's how I do it, right? Now we have a new S here, and I just update, right? I just update this to okay. So since Python the string is immutable, so I need to convert it to basically the as list here. Excuse me, guys. So uh yeah, so I need to convert it to a list here. So the list of I equal to the new C, right? So that's how do we do the update. Now we have a new S, right? And the new S I need to convert it back to the string. I know it's annoying, right? So as list, okay. So I mean, if the new S is not has not been seen before, right? So then we simply add it to the stack, new S, and then we do a scene dot add new S, okay. Yeah, so that's the option A. And for the option B here, right? So it's much easier, right? So we just cut this string by two parts, and then we convert we concatenate them. So the uh, so the first part is we're cutting uh, B's uh, we're cutting B number of strings from the end, right? And then so we do this, right? I mean, this is like a short version of n minus b here. Okay, maybe I'll just do that. So and the other side is also this, right? N minus b. This is how we cut this string here. So same thing here, right? So we can just do the same thing. Yeah. So so every time when we have a new string here, basically we check if this string has been set. That's how we stop this while loop, right? Until the stack is empty, right? So yeah, I think we can just run it. Yeah, so the first one is accepted. Let me try to run this. Yeah, cool. So it's accepted, right? All right, so the time complexity, right? So I mean, so in total, they're like so it's a 100, right? So it's a I mean, so in total, there's only like a 10 times 10, right? So that's only a 100, and then times the length times n. That's the total number of the complexity here, right? Yeah. So that's the mm, yeah, I think so. Yeah, for the time complexity, I think how many different like we have here. I think that there's like a hint here. So okay, so since the length is as is even, the total number of possible sequences at most total number of possible sequences is at most this one. Okay, so yeah, so basically that's the total number of the possible s here, right? So we loop through everything, and inside of each loop here, we do a for loop here, okay, and also this one. So this is actually also a O of n here, okay. So this is also O of n. So inside here, right, we're doing like this n squared. I think that's the total time complexity. Yeah, is it correct? Hmm. Yeah, I think that sounds about right. Okay. Yeah, so that's the time complexity, and the space complexity is this, right? So the total number of is like this. 10 times 10 times n. That's the space. This is the time. Yeah. Cool. I mean, I can see why people give a lot of downvotes for this problem. Even I did, right? I downvoted because I spent a lot of time trying to figure out like a better way of trying to find a pattern for this problem. But anyway, I didn't find it and I wasted a lot of time. If you guys know it, there's like another non-DFS or BFS brute force way. Do let me know. I'm very interested to know that. Okay, cool. I think that's it for this problem. Yeah, thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.